Hello, everyone. This is Master Ritzman, and welcome to another episode of Mathematics Online. Feel free to pause the video whenever you need it and try to solve the problems by yourself. Today, we will tackle about factoring using special products method. The following are our objectives. First, students will be able to recognize and completely factor the difference of two squares. Second, students will be able to understand perfect square trinomials. And lastly, students will be able to explain how sum and difference of cubes works in factoring polynomials. Now, let's try to understand difference of two squares and how it works in factoring polynomials. A term such as 4x to the fourth power is a perfect square if number 1. The coefficient 4 is a perfect square. 2. The variable has an even number for an exponent. To take the square of an even exponent, divide it by 2. Every polynomial that is a difference of two squares can be factored by applying the formula a squared minus b squared is equal to the quantity of a minus b times the quantity of a plus b. Let's try to factor out the following polynomials given below using the difference of two squares. We have a, b, c, and d. In factoring these kind of polynomials, we need to apply the formula a squared minus b squared is equal to the quantity of a minus b times the quantity of a plus b. We remember that we can only apply the difference of two squares if and only if the two terms are perfect squares and can never be applied to any sum of two squares. Now, letter A. Let's try to see if the two terms are perfect squares. 16a squared can also be written as the quantity of 4a squared, since 4a times 4a is 16a squared. That would mean that 16a squared is a perfect square. Then minus 3 squared, the same reason as what we did in 16a squared. Here we can see that the two terms are perfect squares. Now, we can proceed to the next and the last step. Write the first quantity with the difference of the factors of the two terms. We have Then write the second quantity with the sum of the factors of the two terms. Easy, right? Let's go over to letter B. Again, we need to remember that what we need to check first is if the two terms are both perfect squares. Then follow the steps accordingly. Letter C. And lastly, letter D. The next type of special products are perfect square trinomials. Now, when can we consider that a trinomial is a perfect square? A trinomial is a perfect square if and only if the first and the last terms are perfect squares, and the middle term is 2 times one factor of the first and the second term. Observe. The first and the last terms are perfect squares. And the middle term is 2 times one factor of the first and the last term. We always remember the following formulas when we encounter these types of polynomials. Let us try this. Let's identify if the given polynomials below are perfect square trinomials. Letter A. We can see that although the first and the last terms are perfect squares, the second term does not meet the condition. 9x squared minus 15x plus 64 is not a perfect square trinomial because the middle term is not equal to 2 times one factor of the first and the second term. Negative 15x is not equal to 2 times the quantity of 3x times 8. How about letter B? In the given polynomial in letter B, the first and the last terms are perfect squares, and the middle term is 2 times one factor of the first and the second term. Thus, the trinomial is a perfect square. The third type of special products is the sum and difference of cubes. Polynomials with the sum or difference of two cubes can be factored out by applying the following. For the sum of two cubes, for the difference of two cubes. Let's try this. Factor the following polynomials given below using the sum and difference of two cubes. Here is our solution for letter A. In this case, we use the formula. Now, the first step is to build the binomial using the sum of the cube root of A and B. We know that the cube root of A is equal to x, while B is equal to 10. Then use it to build the trinomial. Inside the quantity where you write the trinomial, square the first term. That is x squared. Next, subtract the product of the two terms. Lastly, add the square of the last term. Therefore, the factors of x cubed plus 1000 is the quantity of x plus 10 times the quantity of x squared minus 10x plus 100. Now for letter B. In this problem, we are going to use the formula for the difference of two cubes, which is as what we did in letter A, build the binomial using the difference of the cube root of A and B, then use that to create the trinomial. In the trinomial, square the first term. Next, add the product of both terms. Lastly, add the square of the last term. Therefore, the factors of 8x cubed minus 125 is the quantity of 2x minus 5 times the quantity of 4x squared plus 10x plus 25. And that is all for today. See you in the next episode for another interesting topic. Bye bye!